Hello friends, in this video let's learn about curved beams. We have discussed about straight beam already, but why we need to study about curved beam once again. In a straight beam, neutral axis coincide with the central axis and stress distribution is linear. In curved beam, neutral axis shifts towards the center of curvature and the stress distribution is non-linear. So we need to study about curved beam. That neutral axis lies in between the central axis and the center of the curvature. Always lies within the beam. The neutral axis not shift out of the beam. See, there is a curved beam. We are applying a moment M and radius of outer fiber, radius of inner fiber, and radius of central axis, radius of neutral axis. Consider a portion here and stress distribution in the curved beam will be like this. It's a parabolic, it's not uniform. Here the stress is 0, bending stress is 0, and maximum at outer fiber and the minimum in inner fiber for this section, and the cross section will be like this: radius, outer radius, inner radius, neutral axis radius, central axis radius, and consider a small portion here. Now we applied a moment. Due to this, what's happened, beam will tries to bend like this because we applied a moment. So what's happened, if you want to bend like this, in bottom of the fiber tries to extend, contract. So at here the fiber extended, here contracted. At some region the fiber will not contract. That area is called neutral axis surface. An axis passes through that is called neutral axis. Let's see how to find stresses in curved beam. We can find using this formula. Here M is bending moment about central axis, area of the cross section A, and E is the distance between the central axis and neutral axis, that is eccentricity, shifting distance between central axis and neutral axis, and Y is the distance from neutral axis. It may be from the inner fiber or outer fiber. If positive, when the fiber towards the center of curvature, negative when in case away from the center of curvature. Bending stress in curved beam is 0 at the point other than the central axis. Bending stress other than the central axis 0. For symmetrical sections such as square, rectangle, circle, I-beam with equal flanges, maximum bending moment always occurs inside fiber, at the inside fiber. All the uniform cross section, square, rectangle, circle, maximum stress lies at the inner fiber. For unsymmetrical section, maximum bending stress may occur inside the fiber or outside the fiber, but it can be calculated. But for inner fiber, we can calculate by using this formula, and Ya is the distance of fiber from the neutral axis to inside fiber. And outer fiber we can calculate by using this formula, but only one difference is Ya and Ri, distance of inner fiber, neutral axis from the inner fiber. See, the curved beam was like this, and this one is neutral axis, inside, outside. We applied a moment here. See, now inside, the distance of location of neutral axis from the inner fiber, that is called Ya distance, and distance from outside fiber, that is called Y0, and Ri R naught from the center of curvature. If a section is additionally axially loaded, not only the bending moment, now the beam is subjected to some axial loaded, we must add with the bending stress to get the resultant stress. That is, resultant stress equal direct stress plus bending stress. You can use plus or minus, because in case of tensile load we can use a plus symbol. In case of compressive load, use minus. Bending stress in inside fiber is tensile, while bending stress in outside fiber is compressive. For our section, this condition is satisfied because the beam was like this. We applied a moment here. Now the inside fiber gets tries to extend, and outer fiber tries to contract because of this moment. Formulas are available in design data book. For a design of machine element, for calculating this, we no need to remember this formula. These formulas are available in section 6.1, and we can find the neutral axis radius and central axis radius for different cross section. See here, circular cross section, square, I flange, T flange, here trapezoidal section and hollow section. Everything is available in data book. Easily we can take the formula. Thanks for watching. Subscribe and share with your friends. Thank you.